What's going on, you guys, and welcome back to the channel. In this video we're going to be exploring two things. The first one is going to be list comprehensions and the second is the list module. So the first question is, what are list comprehensions? Now, list comprehensions allow us to kind of iterate or loop through a collection or an enumerable within Elixir. So as you remember from earlier videos, a collection or enumerable is something like a list. So something that we created in the last video where we did this like temporary to-do list where we just put in a bunch of random like to-do items such as eat apple, read book, do Elixir series, and exercise. So with list comprehensions, it would allow us to loop through each of these and say we wanted to kind of look for a certain item. So we want to find an item that has the word book in it, then it'd go through each of these and just return a list of all the items that have that item, have that word we're looking for in it, or the word book. So in our case, it would just return a list with read book. And it allows us to do much more. It allows us to manipulate, of course, like manipulate elements, look for elements, etc. So the one thing I want to do before we kind of implement this within our application is to kind of just get a brief overview of what list comprehensions are all about. So if you head back to your terminal and jump back into the project directory, we can get our environment up and running again if you don't already have it on. So it's just iex-s and then mix. So we can do something like the first one is just a very simple one. Let's just create a random list of numbers. So we can, the way in which we write it, or the syntax for it, is say for, and then like a value or the variable representing the element within a list. And we can say something like 1, 2, 3, and then just do like return that value back. And we just get back a list of the same numbers that we put in. So what we're saying is, for each item in this list, represent each one for each loop we go through. So it will first start at 1, it will assign 1 to I, and then all we're doing is just returning I. And then once it's done with the first element, it will then move on to the next 2, and that will be assigned to I, we return 2, etc., etc. So we can do more than that. We could, let's say, do the same thing and do I, like, and let's square each element. So now we get the first one, which is 1. We look at 1, multiply 1 by itself. So 1 is represented by I, times by I, we get 1. And then 2, we get 4. And then 3, 9. So yeah, that's the first kind of like way of using list comprehensions to manipulate some data. The other one is adding filters to it. So, or actually before we do that, we can also create a list of numbers, and let's say we don't want to add, let's say it's a very long list of numbers and we don't want to add or have to input each number manually. So if we want to do, let's say 1 to, let's say 30, we can do something like, for I, and then 1 period, and then to 30. So it's something like that. So we'll start at 1 and end at 30, including both 1 and 30. We can do, and then just I, and there we have it. We have like an entire list of numbers going from 1 all the way to 30. We can also add filters to it. So let's say we want all the values that are even. So in order to do that, we'll make use of the integer module. But for this one, unlike the enum module, etc., we need to import integer, like so. And then we can do something like for I, and do 1 to 30. And this is where like our filter will come in. So it will come in with here, right after this, like the kind of loop definition. We can say integer dot is even. So it comes with this ready-made function. And this will return a Boolean value. So it will check for each value. So every time, like for I, and check whether or not I is a even number. And then finally we can just do I. And then we have it. We have a list of all the values from 1 to 30 that are even. And notice how like we're getting back a list, and by default a list comprehension will always return a list back to us. You can specify otherwise, however we're not going to go over that in this video. But yeah, that's really how to add like a filter. We could do something like is I less than a certain value, and that'll just be a simple I less than sign, like let's say 20 for example. But we can also loop through two different lists. So let's do for I and then 1, 2, 3 and then comma, and then we can do something like Y and say 4, 5, 6. And we can add each of the numbers up. So we'll do 1 plus 4, 1 plus 5, 1 plus 6, etc. And then here we can do I plus Y, like so. Sorry, so I think it's that. Yeah, I just put like an extra bit of white space there, so yeah, that's why I got this error. But yeah, as you can see, we're getting back 9 elements, and the reason why we're getting back 9 elements is one is we do 1 plus 4, and then 1 plus 5, 1 plus 6, so 5, 6, 7, then 2 plus 4, 2 plus 5, 2 plus 6, and up until we get 9 different elements. So yeah, that's how we can we've looked at how we can loop through two different lists. We've looked at how we can filter lists, and just do the basic list, which is the one that we had here. But yeah, now we can go about looking at how we can apply this to our app. So one thing that would be cool is to kind of look for items that have a certain value inside them. So for example, as I said earlier, let's say we want to find items that have like the word book in it, then we can go ahead and do that. So let's first just test it out. Let's create like to-dos, or let's just call it items. I would just do to-dos dot temp to-dos, and our item has been assigned, items has been assigned to this list. And let's say we want to go through each item, so we can do for item with items, and then we want to use like the string module, and we want to look for if it contains, we can use this contains function. And by default, so contains will first we'll take in like the element that we're looking for, so the word. So we can say item, as item could be any of these, and then we will say like we're looking for something with book, and then we can say, as this will check for it, we can then just go ahead and add the do, so it has to end with this do statement, and we can just say item, and there we have it. We have read book. So it kind of just searches through all of this, looks for anything that has the word book in it, and we'll just return that. So we can go ahead and add this as a function now. So back in the code, we can go ahead and add, set a search method. So search for to do. Actually, let's just call it keyword search. Like so, and this will take in the and yeah, it's kind of similar to like this contains, but I think contains is very explicit when it comes to its match. So yeah, it checks, so like you explicitly have to state like read book, whereas here we're building something where it will just look for does it include this word. and keyword search will take in a list or like our tasks. I'm using tasks and to-dos kind of interchangeably. That's kind of like a little problem, but yeah, hopefully like when you see tasks here, just think of to-dos, our to-do list, and then also what we're looking for. So word, like so, say do, and we can say string dot contains. Actually, sorry, not that. We will just do for tasks string dot contains, and we can say the task and the word, and then just do or we can just say do like so, and then we just want to return the value that we just get back from that. So the tasks that have this word in it. So we can just remove that and just do, and then just say task, or what did we have here? Yeah, task. So if we go back now, we can just recompile, and we can put in to-dos dot keyword search, pass in items, so our list, and then let's say we want something like looking for Elixir, and there we have it. We get back a item that has the word Elixir inside it. So that's the first thing that we're going to look at when it comes to like using the list comprehension. Now we'll look at like a main part of it, which is when we already we have something when it comes to when we create to-dos, we get like a message which asks us to input the number of to-dos we want to add. So if I just clear this, we do to-dos and then create to-dos, and it just asks us the number of to-dos we want to add. Let's say like 5, and we just get back the number. But we want to like extend on this and kind of add something where based on the number we enter here, we want to create to-dos based on that. So one thing I want to just show you is how we can like the kind of template we'll use. So we can do let's say for I, and we can assign, let's say from 1 to 3. We want to do, and if you remember, like we want to make use of this IO gets to get like the input. We can say do IO.gets enter something. Let me just put a space there. So we hit enter, and now we should expect this enter something to show up 5 times after we've each time we enter some value. So yeah, we're getting this variable I is unused, and that's because we haven't put an underscore, but this is just a warning. So we can say eat apple, read a book, go for walk. And there we get a list of all the values that we've entered along with a new line. And the reason why we're getting a list is because this io.gets will always return the value that we entered. So it will take eat apple, so it'll do eat apple, okay, put that in a list. Read a book, okay, put that in a list. Go for walk, okay, put that in a list. And then once this condition has been met, once I has reached 3, it'll stop, and then it'll just throw all of our items back into this list and then print it or return it back to us. So that's what we'll use now to get the number of tasks, or to write down the tasks that we want. So to begin with, if we go back now to our create to-dos function, we can start by implementing our tasks. So we can say something like, we can first of all get rid of this number of tasks. So we'll just say for, and we'll just say underscore because we won't make use of this variable, for the values from 1 up until the number of tasks. Oops, let me just copy this. For some reason, like my text editor can be quite slow, so it's not auto-completing for me, but we can do, yeah, from 1 up until the number of tasks we entered. We can say tasks equals io.gets enter task, like so, and then we can just use the trim method, this trim function, sorry, and what trim does is it basically just removes any like trailing white space around it, so we don't want this like this new line, so that's what we'll do. We'll just get rid of that, and we can just say not tasks, we'll just, it's going to be singular, so task like so, and there we have it. And because this will return a list anyway, we don't have to like specify like or collect it all up. It's just, yeah, this is a list, it creates a list. So now if we go back, we can just recompile and we say todos.create todos. Let's say 3, enter a task or enter task, read a book, watch movie, go for walk. And we get back a list with all the values that we've entered. So yeah, one thing, however, is if you've watched the last video, we went over something called the pipe operator to just kind of really clean up our code and make it just feel a lot more streamlined. This can all be just, we can use the pipe operator here, so we can just kind of just turn all this into like one line of code. And to do that, we can just, yeah, like say io.gets enter a task, and then this will return the value that we enter, and with that value that we get back, we want to just send that to string.trim, like so, and just leave it like that. We can get rid of this, but yeah, essentially whatever return value we get from here, throw it into here, and then that will be added to this list we'll get back. And yeah, if you haven't like, if you're not familiar with with pipe operators, then I definitely recommend going back to my last video and watching that, as that's what we did with this stuff here. We kind of replaced our old code with, or we used the pipe operator to kind of improve on our old code. But yeah, that's essentially that. So we can go back, just save this, recompile it, just clear it, and we can say, we can like assign it to a list. So my tasks, we say todos dot create todos, enter the number of todos you want to add. Let's say 4, eat apple, read book, watch movie, go for walk. And now all this has been assigned, because we're returning a list, this has all been assigned to this variable my tasks. So if we do my tasks now, we get this back. And then we can apply this to, let's say, our contains, or not contains, well, we could apply it to contains, but our keyword search. So we can do todos, keyword search, and let's say you just want to look for, so wait, we'll just pass in my tasks, of course. And let's say you want to look for, like, do I have a to-do item that has the word walk in it? And we can say something like walk, hit enter, and it looks like we do. So we go for walk. And if we did something like book, we'd get back read book. But yeah, that's really like list comprehensions, or at least the basics of it. If you're curious about looking into it more, then I definitely recommend, going to the Elixir docs, and also elixirschool.com or .org, whatever it's called. There they have like a really like easy to understand examples or easy to understand explanation of how list comprehensions work. But that's with list comprehensions. We'll now move on to making use of the list module. Essentially what the list module is very similar to like the enum module or like the string module, as it comes built in with Elixir. So if we head back to the docs, I'm on the list page. So really what lists are is they're very similar to enums. However, or the enum module, however, the list module is focused solely on lists, not so much collections or any other form of enumerables, just specifically for lists, which is great because we have our to-do list is represented as like a simple list where we just have a bunch of items like eat apple, read book, watch movie, go for walk, etc., or whatever you want to put in, but it's just a list of strings. So we'll be making use of the list module to add some extra functionality to our app. And the one, feel free to go ahead and read all of this and get a better idea of what the list module is all about and the sort of functions that come with it. But there is one that we'll be using, and that is the delete module, or delete function, sorry. And the delete function, you basically give it the list and also the element, that you want to delete from the list, and it returns a new list without that element. So one thing I don't think I've kind of explained, well, at least not in this video, is that we can't mutate like variables or like values of variables, like lists, for example, sorry. So we can't mutate the list. So here, for example, we have like my tasks. So if I do my tasks, we're not allowed to say like add a new element to this or remove an element from actually my tasks. Like in order to do that, like with the delete function, is we pass in a list and the element, and then it creates a new list just without that element. So you could imagine it as like when we did the for loops, it could be a for loop through that list, and or sorry, not a for loop, a list comprehension of that list, and then filtering out for the value that we want to get rid of. And that's essentially, I guess that's probably how delete would work. So we can go ahead and just try that out, and we'll use that to kind of basically when we complete a task, we just want to remove it from the list. So we can do something like complete task, and this will take in the tasks. Again, I think I really should rename it to like other stuff like to-dos. So complete to-do, just pass in, keep in line, we'll call these tasks for now, but you get the point, tasks, to-dos, whatever. And then the tasks that we want to delete. And then what we can do is first check to see if that task exists. So we can do something like if, and yeah, this is kind of like a first kind of look at if statements. And I'll explain, like if you're not so familiar with if statements, then I'll explain like in a second. So if contains tasks task, so we're making use of this function that we wrote, and then do, and we can also do an else. So essentially, so execute this block, and otherwise execute. So yeah, if you're not familiar with if statements, then it's basically we're checking to see if something is true or false. So in this case, we're checking to see if tasks, or if a task exists within like our list of tasks or to-dos. And if that's the case, then it will execute whatever code's in this, like between this if and else. Otherwise, if it doesn't exist, then we'll execute the code that's in here. So if the task does exist, we can say list dot module, or not module, list dot delete, pass in the tasks and the task. If it does, however, then if it doesn't exist, then we can return an atom. We say not exist or not found, error. So yeah, we haven't really gone over atoms either, but essentially an atom is the value of its own name. So for example, not found error is equal to just, it's the name of what we've given it. So not found error. We could easily just return like a string, so like not found error here, but like with atoms it's a lot more clearer, and it's just, I think even with when it comes to the like auto completion in code, it knows that it's looking for not found error. We don't have to type out like a string and get like errors if we type it in correctly. So yeah, that's what an atom really is. But yeah, like if essentially we've created a function that deletes or completes a task by deleting it from the list. So it'll check to see if that task exists. If it does, then it deletes it. Otherwise we get an error, a not found error. So we can go ahead and check this out. So, and this will also give you an idea of what I mean by immutability. So we have my tasks like so. We can just quickly recompile. We can say to-dos dot a complete task, complete to-do, pass in my tasks. And let's say we want to complete watch movie. Hit enter. And we get back a list just without watch movie in it anymore. But if we do my task again, my task, sorry, we get back the same or the original list that we had before. So in order to kind of update this, we have to set my tasks to the list that we get from here. So I'm just going to copy that and say my, or let's say like, like new tasks, or better still, updated tasks. And we can just say that. So now we have updated tasks, which is eat apple, read book, go for walk, just without watch movie, as we've now completed that. So yeah, that's basically completing a task. We can even try out something else where, let's say we did, we typed in something that doesn't exist. So we can say something like, jump up and down. And then we get this not found error that this atom that we created. So like it's even highlighted quite nicely here. So yeah, we know that, okay, we're getting back this not found error. The value of this atom is the name itself. So not found error. It's a bit confusing at first, but I think like, yeah, as we go ahead, we'll make use of atoms a bit more in the next video. So you'll kind of see the kind of usefulness of atoms. But yeah, that's the kind of complete to do. We can also try out something else. So let's say if we want to update our list. So we can do something like, I guess, insert at, like to kind of just add like a new item to our list. So we can do like something like add new to do, and we can say so like we'll need to give it the list itself, so tasks, and also like just the task that we want to add. And by default we just want to add this to the end of our list. So what we can do is do list dot insert at. So insert at, we have to give it the list, the index, so where it is in the list, and the value that we want to add. So to give you like an idea of how this would work, so let's say we created let's say basket, and that will be a list of, let's say, just a bunch of items. So apples, pears, and mangoes. So yeah, we have this basket. We can use the list module, and if we do dot insert at, and we have to pass in the basket, and then we have to give it an index. So I think like all languages have this zero indexing, where The first element has the index of 0, so apples is assigned to like this index of 0, pears is 1, mangoes is 2. So we can say, like, as it takes in an index now, we'll say insert at the end. So a list could be, let's say insert at the beginning, and we want to add, let's say, berries. So now we get back a list of like our original list, but berries inserted at index 0, and then everything else like kind of shifts along. So apples is then assigned to 1, pears 2, mangoes 3. But if we want to add this to the end of our list, there is another kind of shortcut that we can use, because we don't know like how long a list could be. So like it could be 4, it could be 3. We could put something like, instead of 0, we could say something like 2. So like mangoes already being 2, we could add berries to be 2 as well, or assign berries to 2. We can do that, but a nice way to kind of say I want to add it to the end of our list, because usually when it comes to writing to-do lists, we tend to like add the to-do item at the bottom of our list. So it'd be nice to like just place it there. So in order to just add that there, we just need to put in -1. And that kind of like starts off at the beginning, or the end, sorry, of our list. So if I do that now, we have berries added to the end of the list. So we can kind of like use that now as to add that into our list here. So we can say insert at tasks, and then index -1, and then the task, and that's really it. So we go back to like my tasks. So we've got these 4 things, and let's say we want to add something. So we do to-dos dot, what was the name of it? Add new to-do. Oh, I need to recompile. Sorry, recompile. My task is still the same. And now we can do to-dos, add new to-do. And we can pass in my tasks. Sorry about that noise, it's just every time I guess I hit the end of a line. My tasks, and say clean flat. So now we've just added, still got our original list, but we have a new element that we've added, so clean flat. And again, like if we did my tasks, like we still have our original one, because we're not like changing my tasks variable itself, as we're not allowed to do that. So we could say like updated to-dos, and just assign that to the value, this value here. So now if we do updated to-dos, we get back our original list, but also with clean flat. But that's really it. So we've kind of looked at we've looked at list comprehensions, and we've also gone ahead and looked at a few of the functions, or a couple of the functions that come with the list module, and how we can delete elements, we can add elements, etc. There's a bunch of other things that you could probably try out. There's a bunch of them, but I would suggest to kind of mess around with this and see what sort of things you can come up with. But other than that, would kind of conclude this video. I hope you have now like got a bit of a better understanding, or a good understanding of how list comprehensions work, and also the kind of uses or functions that come out of the list module. But other than that, I wish you all the best. I hope to see you in the next video. And if you enjoyed this video and it added some value to your life, then please give it a like and subscribe. But other than that, stay safe, stay healthy, and I hope to see you in the next video.